All right, so I'm going to introduce really quickly attack vectors on Lightning. I'll focus on first what you can do with the Lightning protocol, but um, I'll mostly speak about how attacks will probably happen in real life. It's probably not going to be direct attacks on the protocol itself. So the basic attacks you can have when you're running Lightning nodes are denial of service attacks. Basically, Lightning nodes are servers that accept incoming TCP connections. You can just overflow the servers with connections, and that's something that is extremely hard to fight. Basically, fighting low-level connection DDoS is really expensive. You can use services like Cloudflare, but it's really expensive. And if you don't, what's going to happen is your your hosting provider will eventually disconnect you from the network. It will null route you because DDoS attack against you will have an impact on everyone else in the same data centers, and you will be effectively disconnected. So that's really, really hard to fight. There's an ongoing DDoS attack against Electrum servers. I don't know if you've heard of it. They are blacklisting, I think, 150,000 IPs right now, but it's a battle that is really hard to fight. Something that is really easy to do with Lightning, but it's a bit costly, is to just lock up channels. So you have limitations in Lightning. You can't have more than you can have too many pending payments, and the amount of your pending payments is also limited. So you can just lock up channels. You can just send HTLCs with random pre-images, and after a while, channels will not accept more pending payments. However, this is not free. So can you tell me why it's not really free to do that?
You also look up your own channels.
Yes. So it can be really annoying, and if you choose really long routes, you can like lock 10 times your funds or even 20 times your fund, but it's still expensive for you. You need money to do that, but it can be really annoying.
But it's asymmetrical, right? It's you pay one, you can get the benefit is 20 times.
But 20 times is not that much, so you can't really perform a large scale attack with this type of locking up funds.
Potentially with trampoline, you could also do like longer than 20 paths, right?
Yes.
Also, if you're paying it, you're locking it up, but then eventually you get it back. So it's like an upfront cost of attack, right? But eventually you get paid back.
Yes, but it can still be a bit annoying. There's also resource usage attacks. If you look at the type of queries that Lightning nodes are supposed to serve, some of these queries can be quite expensive, and especially the syncing your routing table is really expensive, and using range queries can also be a bit expensive. So if you connect to a node, you request a routing table dump, you disconnect, you try again, you disconnect, you try again. This can be really annoying for the serving node. So that could also be used to just lock up resources on your servers. And something that is really bad, but it's something that happens with most protocols, is reusing random values. If you pay once, suppose Alice buys something from Carol, she pays once. And for some reason, Carol, her website is not too good, it's reusing the same pre-image. So now Alice would try to pay a second time. But if someone has seen that pre-image, if Bob knows the pre-image of a payment it's supposed to relay, it will not relay it, it will send back the pre-image. And this is really bad because Alice will have a valid proof of payment. She will have a payment request signed by Carol. She will have a matching pre-image, so she can go to Carol and say, I've paid you. Give me whatever you're supposed to send me. It looks pretty bad, and there are many, many ways you can end up with bad random generators. There are many ways you can end up with reusing values that are supposed to be random. And if you try to be clever, if you try to come up with a nice scheme for generating payment hashes and payment pre-images, this is a bug that you could actually hit. And it's really bad. There are probing attacks. I think this is the topic of one of the next talks, so I won't delve into it. But basically, with Lightning, you can do probing attacks because you can use the fact that nodes will not behave in the same way if they are the destination for the payments or if they're not. So using different error types that are returns may help you learn who is supposed to be the final destination of a payment. You can also try to guess the balance of a specific node using other kinds of probing attacks. So they're tedious to set up, but it works because nodes will not behave in the same way if they are or are not the destination of a payment. A very simple way of attacking Lightning nodes is just to try to cheat and publish revoked states. So as we've seen, if you do that, there's a window, a time window during which the other node can steal all your funds. So this is an open question for you, something you have to think about. How do you prevent someone from using the revocation key and steal all your funds if you're trying to cheat? We'll get back to this later, but suppose you want to cheat. What could you do to prevent the other guy to punish you if you publish your old state? One of the things that we've done with the mobile app to fight this is to use really long CLTV delays, long penalty windows, but it's bad UX because it means it has a problem. Your phones are locked for up to 2 weeks. And if you're offline for a really long time, like if you take a month off to go hiking in Nepal or whatever, then you need to close all the channels. Otherwise, you may lose them. So Watchtowers, I think we've described how they work. But the consensus now, even though not everybody might agree with it, is the penalty ID may not have been such a good idea after all. And I don't think anyone is actually trying to cheat right now. So the few penalty transactions that have been published were published because someone messed up with an old backup. And they weren't punished for making mistakes, but not punished because they were actually trying to be evil. So L2, that's my opinion, is a bit better. But I understand why some people still want the ability to punish bad actors. But honestly, I don't think that attacks, again, Lightning nodes will attack the protocol. So I used to work for a security company for some time. My first job was in defense industry and then security industry. We still work with security consultants, and basically, if someone was to attack Lightning, they would not attack the Lightning protocol, they will attack the implementations. That's what is really likely to happen. They will look at some of you worked with security companies or pen testers. So there's one thing that is really funny with these guys is you can work on building things or you can work on attacking things, but you don't do both at the same time. So pen testers and white hats, very often they are developers, but they will not work on building and defending on the same project. So you choose a team to work on building something and a team to work on attacking the same thing, but they're not the same people. It's like I think the American football. I don't know that much about football, but you have defense teams and attack teams, and they're not the same guys. And maybe people can play defense and attack, but not in the same games. And with security companies and pen testers, it's the same. guys will sometimes build things, or sometimes they will attack things, but they won't do the same type of work at the same time because the mental switch is really difficult to do, even for really experienced pen testers. So what this means, and that's the bad news for us, is teams that build things are really bad at understanding how to defend their software against attacks. You need to bring in people who would just look at it and try to break it. When you're building something, even if you're very careful, you think about what is supposed to happen. But when you're attacking things, your state of mind, your vision is very different. You all know the $5 branch attack, okay? And it's something that you see in many actual attacks against systems, physical or software attacks. For example, this door, suppose, I don't know what kind of lock it has, but suppose it's a really, really fancy lock, very expensive, it's almost impossible to open, but the door is plain wood. It would probably take 20 seconds to just cut a hole into it. It would be too noisy, and then you're in. And the fact that the lock is super strong and impossible to defeat doesn't really matter because it's just plain wood. And that's basically what happens with most actual attacks on things. And the fact that software is open source is not always a good point because it means that it's very easy to study the source code and find issues. And that's every pen tester we've met has told us the same thing. Being open source is not a silver bullet. It doesn't give you magical powers. What it means is people can actually look at what you're doing and understand weaknesses, and they will not attack you right away. They will wait until it's worth it. So I think, I'm not saying open source is bad. I mean, everything we do is open source, but I'm saying that the feelings that is everywhere, that because it's open source, it's safe, because people look at it. It's not that true. There were huge bugs in OpenSSL. Some of them have been there for a long time, and no one saw them. There was a really funny bug. I think it was Ubuntu a few years ago, where you would hit backspace like 20 or 30 times, and you would just bypass login checks. And there was another one. I think it was also Linux. You would remove the hard drive, and basically you could bypass login checks because there was no more password to check against. So that being open source is not always a silver bullet. And for example, there's an ongoing debate when it comes to hardware wallets. Is it better to have open source firmwares or to use secure elements? If you use secure elements, you can't have open source firmwares. You have to sign NDAs, and I think you can't publish. So on one side, you have Ledger, and the firmware is not open source. On the other side, you have, I think, Treasure. It's open source. Which is better? It's really hard to tell, but
Multi-sig.
yeah. But I personally think that using secure elements is probably today a bit safer than relying on open source firmware. But
the problem in closed source is then you get to a situation like was 2 months ago that almost all the SSDs out there were faking about encryption. Everyone thought they were doing disk encryption, but it was all fake. The SSDs lied about the encryption and didn't really encrypt anything. Samsung and Corsair and all of the huge companies lied about the encryption. It wasn't encrypting anything. So Trezor might do the same. It might not even be an HSM really.
You mean Ledger?
Ledger.
Yes, I'm not saying because it's closed source it's better, but I'm saying that secure elements are probably extremely safe today. There are no publicly known attack against secure elements, and it's a trade-off between being really open and being really closed source. But for example, one thing that I find really funny is almost every pen tester I've talked to says that Chrome is much safer than Firefox. If you worry about security, you should use Chrome. It's bad, it's Google, it spies on you and everything, but there are very few 0 days against Chrome, and people found a 0 day against Firefox, I think, just 1 or 2 weeks ago. So it doesn't, it's not something you want to hear. But if you really worry about security, maybe right now, and it's sad, but Chrome is a better choice than Firefox. And we all use Chrome async. There's one thing so what I'm saying is, if you want to think about how to secure Lightning nodes, how to attack Lightning, look at the implementations, look at how they run, look at where they run, which cloud provider they're using. This is what people are going to attack. They will not attack, they will not find a subtle flaw in a protocol or whatever. They will just find bugs or remote exploits or buffer overflows in implementation, and this is what will be attacked. The wallets you use. So if you run a Lightning node, you have a hot wallet because you need to be able to open channels, and then you have the actual Lightning wallet. It's another kind of hot wallet with different constraints. A lot of people are thinking about using HSMs to protect the Bitcoin wallet and the Lightning wallet. And protecting the Bitcoin wallet is fairly difficult because the problem is automation. You know how the hardware wallets work. You send a transaction to the hardware wallet, it will display the address you want to send money to, and if the address is right, you will press a button and it will sign the transaction and return it back to you. This is fine if you manually interact with your wallet, but what if you want to automate things? Suppose you run a big service, you need to sign like big transactions all the time. How do you won't have people clicking on buttons every time you want to send something. So they end up with another issue. It's very easy to over-engineer security solutions, but if it's impossible to steal your keys, but it's very easy to get your system to sign anything, then you don't have any kind of security. So if you focus on protecting keys, but you forget that what you need to protect is the ability of people to use your keys to get your system to sign, then you're missing the point and you're not that safe. And it's a problem with a lot of Bitcoin applications. And it's something that all hardware wallet vendors are working on, but it's pretty hard because there are very few things you can check when you're signing Bitcoin transactions. Lightning, it's a bit different. There is something you can do that should prevent people from stealing from you. So what that is when you are relaying payments, you can try checking that for every outgoing payment, there's a matching incoming payments. But to do this, you need to understand what's going on, which is a bit hard. There's something else. I think it's an attack that was described by Stepan Snigirev 1 or 2 weeks ago. And I want you to think about it. So I'm Bob in the middle, and I'm relaying payments. And Stepan says, what happens if the channel between Alice and Bob is closed, but Bob doesn't know it? Basically, what happens if you manage to stop blocks from the Bitcoin blockchain to get to Bob, you blind him, and it is not seeing that the funding transaction of his channel with Alice has been spent. So the attack is Bob does not know that the upstream channel on the left is closed, and it will keep on relaying payments. So do you think it is actually a problem or not? Do you think it is safe, or do you think Bob is losing money because he's paying on this side, and on this side, well, the channel is closed, so it's
Wouldn't they have to be making it so that Carol couldn't see that because Carol determines the route?
No. Basically, Alice has managed to stop blocks from getting to Bob, so Bob doesn't see what's going on the blockchain. It doesn't see new blocks coming in. So Bob thinks that the channel from Alice to Bob is still open. So what Alice is doing now, she's sending payment to Carol through Bob. And basically, Bob will relay payments, but he doesn't have actual incoming payments because that channel doesn't exist anymore. But is it really bad?
I would have to be offline long enough for the timeout that the channels to expire, right?
That doesn't Carol,
But you can
doesn't Carol conspire, and they just keep sending payments, like they can make it so Bob is sending the payments to Carol, but he cannot get them from others anymore.
But in order to get the HGLC, you have to.
I can leave this as an open question because I think there's a session on DOS attacks against Lightning nodes. But basically,
In order for Alice to for Bob to receive the HGLC, Alice has to revoke the old state, no?
yes, you're getting there. So, what happens if you try to use a channel that is closed but you don't know it?
You can't claim. I mean,
Okay, I'll let you think about it, and we'll come back to this during the next session. Basically, the question is,
you can claim if
the channel between Alice and Bob is closed. Bob doesn't know it, so he keeps on relaying payments from that channel to other channel. Is Bob losing money or not?
depends if the timer has.
It's not a question of time.
I think it's a question of time.
It's not just that.
It
So,
can be eclipsed for like 2 weeks or whatever, like the revocation.
He's putting HGLCs into a commitment transaction that cannot go on chain anymore because it's already
Yeah.
another version of
That's the
Jamlock.
problem.
okay, I'll give you the answer later. Okay, so the question is Bob losing money or not? So you have to choose. Yes, Bob is losing money, or no, Bob is actually not losing money.
No.
Yes.
Maybe. Schrödinger's channel.
Oh, wouldn't happen with L2. Just so that I said it.
And there's something else I'd like to mention.
It would happen with L2.
That again, because when we think about security and what to do to protect things, very often we get the wrong picture. Speaking to actual pen testers is really enlightening because they give you they have a completely different thought process and they look at things in a way that is completely different. And one of the things that happened a few months ago was a successful phishing attack against Electrum servers, and it does not target the Electrum protocol at all. Yes, what it does is, and it's something that everyone should be worried about because it's really easy to overlook this. Basically, the Electrum displays error messages to the users, and error messages come from the servers you're connected to. And some guy said, okay, I'm going to display a message that says, you need to upgrade, go to that link. And that's what people did. And you download a really bad Electrum client and your money's gone. And it's really hard to fight because the server, the actual Electrum client, is showing you a message that says, go to that link and upgrade. So you trust it, especially if you not really an expert. You do what it says, you click on that link and your money's gone.
How do you show error messages in the audience that are being returned?
It's an open question, but basically when you design stuff that is supposed to be used by anyone, what do you do with inputs that you have no control over? What do you do with messages that you receive? What do you do with error messages that you receive? What do you send as error message? If you have a crash or an exception, do you basically take the stack trace and the error message and send it to your peer saying, okay, this is the error I got? Or do you convert and sanitize everything? And that's a very simple way of attacking software. Like you cause it to fail, you send it garbage, and you look at what it returns. And in some cases, it will return a lot of information that you can use later. It's a bit like, does everyone know what side channel attacks are?
Yeah.
Okay, but if I ask you to write software to compare two strings, what you will come up with will probably be very weak from a security point of view because you will stop as soon as one of the characters is not the same, which is really bad from a security point of view. And that's what I was trying to say when I said that when you're building things, your state of mind, even if you're really careful, is not necessarily good for security, which is why it's good to have people who are not trying to build anything, they're just trying to look at how to break what you're doing. And to really work, they have to be a different team. It can't be the same guys. And think about this one. There's no channel between Alice and Bob. Bob is rolling payments. Is Bob losing money or not? Yes. I'll give you the answer later. Okay, that's it for me. Questions?
Where's the next hardware store? I need a wrench.
Okay, thank you.
Sorry?
We're a little tight, so we'll bump it to the afternoon.
Okay.
Maybe we could do the discussion now.
Sure.
Does that work?
Yeah.
So,
But I was ready.
good. You can still be ready. Start again. So, we're actually done with presentations for the day. It's going to be discussion based and exercise based for the rest of the day. Just want to show you your groups so that we're prepared. So it's 3 different groups, and it looks like this. Cool. Everybody got that? Yep. And the first assignment for the next, let's say, 10 minutes or so is to get together with your group, and we have 2 asks from you. What are the hot wallet risks? Just in Lightning, generally. And then denial of service attacks. Why don't we talk about why don't we actually put together some lists of what we should be concerned about, and then we'll convene again as a group and talk about it. Cool? Feel free to get out of the room. We'll see you in about 10 minutes. Yeah, all the groups are talking about the same thing.
Jonas, how do you plan to do this with the gossip privacy questions? Every group a different topic, or because we could boil it down to 3. I mean, taking the IP address stuff to the gossip stuff would be
Yeah, I think let's put it down to 3 and have each one have their own section.
I mean, I suggested to remove the 5th one, but I mean we can merge the IP stuff with the first one, and then we can basically have the same groups again, do 10 minutes, and
That would be
do
great.
presentations.
Yeah.
That would be perfect.
Cool. Awesome.